Hey there, let's go ahead and talk about compositions of functions, an important and frequently assessed topic on the AP Precalculus exam. This is lesson 2A-8, and you'll be successful if you can evaluate a function for a given input, understand composition notation, and apply composition to functions defined numerically, graphically, or analytically. So let's talk about what composition is. Composition of two functions is when the range of an expression that represents the outputs of the second function ends up becoming the domain or input of the first function. Essentially, you have one function embedded within another function. Now, there's two ways that you can go ahead and see this. We have, again, and they're both pronounced the same exact way, f of g of x. So just notice the difference in notation. I believe this is called like fog notation. I've heard this called, but the most common, usually they'll write both of them, but number 2 is the most frequent, f of g and then of x, okay? And so here's the idea, is that we're going to go ahead and evaluate, and usually you start on the inside. So I evaluate g of x first, and so I take those domain values, and whatever ends up coming out goes into the secondary function, ends up becoming, the range ends up becoming the domain of your outer function. Okay, and so let's go ahead and see kind of how this works. So here they say the table of values gives values for g of x for select values of x. The function f is given by f of x equals 2 to the power of x plus x. Find the following. So what's very important to note is that, again, we're going to start here on the inside, and that this 5 here, g of 5, that's an x value. That's your input. So we go to my table where we can evaluate g. So I have to find my function. So I'm going to use my table, not my algebraic function over here. And they want to find 5. So the input value 5 is right here. Here's 5. And then, so what is my output? What's my range of g at 5? It is -1. So what we end up getting now is we get f of -1. So that's like evaluating a function normally. Now I just have an answer that ends up I have to use again. So now I have -1. Now I have to evaluate f at that location. And so I'm going to go ahead, I'm going to plug that into my function up here. So we get 2 to the power of -1 plus -1, and this gives us 1/2 minus 1, which equals -1/2, or -0.5. Okay. Example 2, f of g of 3. Again, start on the inside here. G of 3. 3 is your x value. So I'm going to go to 3, and it looks like my output is 2. So now I have to find what's f of 2. And then we go ahead and just plug it in. 2 squared plus 2, and we end up getting 6. Okay, so I want you to go ahead and pause the video and try this one here, f of g of 2. What do you get? Okay, hopefully for this one you got -63 over 16. At least hopefully you got 2 to the -4th minus 4. So that's 1/16, 1 over 2 to the 4th, 1/16, minus 4. And in order to combine these, you have to have a common denominator. So I multiplied top and bottom. I multiplied this 4 by 16 over 16, which gave me 64 over 16. And then your final answer, -63 over 16. Okay, let's go ahead and look at, again, a similar idea here, except we'll do something that the AP exam loves to do. They'll give you information. F is in a table of values for select values of x. G is given in an algebraic form here. And then they define a third function, h. And they say h is equal to g of f of x. Okay, so they say here, what is h of -1? Well, h of -1 is going to be g of f of -1. So now, again, I'm starting with f. So always start on the inside. So f, I got to go to f, which is, again, the table. So start at -1, and my output is -2. So now I have to find g of -2, which gives me, I end up getting 2 to the power of -2, minus 3 times -2. So we end up getting, what, 4 plus 6, which gives us 10. Not too bad, right? Start on the inside, work your way out. Okay, example 2, h of 2. All right, here, h of 2. This is going to be g of f of 2. And I'm going to start, again, with f of 2. So here's 2, and I get 1. So we have g of 1. And we'll plug this in. So we get 2 to the negative first minus 3 times 1, which gives me 1/2 minus 3. And find a common denominator. 1/2 minus 6/2 equals -5/2. Or -2.5. -2.5. I know some of you are allergic to fractions. So if you like the decimal, that's fine too. Okay, last one here, h of 1. Please pause the video. I want you to try this example. Okay, here you go. G of f of 1. F of 1 using the table returns 0. So g of 0, you plug that in, you use the 0 exponent property. I know it's a -0, but ends up still being 0, right? So you get 1, and then minus 3 times 0 is 0. So you get 1 as your answer. Hopefully you got it. All right, let's go ahead and look at composition involving graphs. The function f defined on -1 to 6 is shown to the right. The function g is given by g of x equals x plus 2. Which of the following is the graph of y equals f of g of x? So here's my graph of x, of f, right? So this is f of x. This is f of x as it is labeled here. And they want to know what is y equals f of g of x. So g of x, very important to note, is this function right here, x plus 2. So I can replace g of x with x plus 2. Okay, and now we have a transformation situation going on. So what happens to my graph of f if I add an h value here? Okay, so very important to note, hey, right here, h is equal to -2. And so what I expect is my graph to slide 2 to the left. Okay, so I can take this point right here, which is at 6, and it's going to end up moving right here. And I can take this point right here, and it's going to end up sliding to 3 right here. So I should have a graph that would look something like that. Now at -3 and at 4. So I think I like A. Yeah, this one went to the right 2, this one went up 2, this one went down 2. So, yep, slid to the left 2. All right, and last example we have here for this lesson, same idea. I have a graph f defined on -5 to 2. The function g is 2 of x. Which of the following could be the graph of y equals f of g of x? So again, the graph I'm looking for is y equals f of g of x. And g of x here is defined as 2x. 2x. So what does this do? What does this do to my graph? Well, this is a c value that's 1/2. That's going to be a horizontal compression by a factor of 1/2. So you can look at this graph here. I'm at 2, and if I take 1/2 of those values, I'm going to be at 1. And then again here, I can take this value at -5 and go to -2.5 right here. Okay, and so our graph would look something like this. You get a horizontal compression. So I don't like A. Boop, throw that one out. I don't like B. That one kind of looks similar. Oh, it looks like they stretched it vertically. D, they compressed it vertically. So it's not D. Answer here, C. Okay? That's the idea behind composition. You just take whatever's on the inside and you plug it in, and then you evaluate the outside. Okay? So hopefully you learned about composition notation. Hopefully you learned how to evaluate a function with composition, and you could do that involving an algebraic equation and a table. Catch you in the next video. See you later.